Kirk math. All right, welcome ladies and gentlemen. We are looking at 12.1 Pythagorean theorem. So get your notes ready because in this lesson we're going to learn about the Pythagorean theorem and how to write it, and we're going to understand how to solve the missing side of right triangles using the Pythagorean theorem. All right. So the very first thing we need to do is understand what is the Pythagorean theorem. So the Pythagorean theorem is only for right triangles. So we're going to make sure that we put that in our notes a little bit. We have something called legs, A and B, and a hypotenuse, C. And you've probably heard that, you may have heard this before, where people will say A squared plus B squared equals C squared. This right here is Pythagorean theorem. Now, what in the world does this name have to do with anything? Well, Pythagoras, okay, right here, he used to be a Greek philosopher, and he or some of his students had discovered that if you take a right triangle, like the one that's behind his head here, you can find the side length of one of the sides, knowing two of the other sides, by doing this formula right here. And they basically would draw on the sand, and they would kind of use that information to figure this out. A theorem is something that has been proven true based on things that we already know are true. So this is something that we know is true because of, and you'll see, because based on other things that we know are true. So let's take a deeper look. So legs, the legs of a triangle are the two shorter sides. They are connected to the right angle right here, okay? It does not matter which one is A or B, but they are the two sides of the triangle that are touching the right angle. You also need to know what a hypotenuse is. A hypotenuse is the longer end of a right triangle. It is the side that is directly across from the right angle, and that is always going to be C. So our hypotenuse is C, okay, and you'll see that on the next page, and then our legs are A and B. You should be taking these notes down in your note taker. All right, so now we can see here we've got legs A and B and our hypotenuse C. So when I read this again, it says the Pythagorean theorem for a right triangle with legs A and B and hypotenuse C, A squared plus B squared equals C squared. But again, what does this mean? This is just a bunch of letters. So if we take a look at this picture here, you can see that A, which in this case is down below, and B doesn't really matter, but we're basing it off of this arithmetic equation right here. And if this is C, think about squaring like in geometry. So A, which is 3 units long, squared, so that's 3 times 3. Okay, that's 9. B, which is 4 units long, and then they squared that, 4 by 4 is 16. Okay, so this is 9 and this is 16. If I take these two together and I add them together, they are going to equal C squared. So C, the length of the hypotenuse, 1, 2, 3, 4, 5. Okay, squared, that's 25. So A squared, which is 9, plus B squared, which is 16, equals 25, which is C squared. And that is a true statement. So that is what Pythagoras figured out, is that this works on any right triangle. So what we're going to do today is apply that and figure out how to find the missing angle if I know A and B, or if I know A and C. All right, so here we go. We've got a couple things here. We need to find our missing triangle. This guy is directly across from our right angle, so that means it is our hypotenuse C. So again, I'm going to use Pythagorean's theorem, A squared plus B squared equals C squared. And I'm going to go ahead and take what I know. Now this is A and B. It doesn't matter which one's which, but I'm going to go ahead and say it's 7 is A squared, 24 is B, 24 squared is going to equal C squared. And what we're going to do is use that math like we did in our order of operations and like we've done in solving for a variable, and we're going to go ahead and solve this problem. So the first thing we're going to do is our exponents. So I'm going to do 7 squared, which is 7 times 7, which is 49. And I'm going to add 24 squared, which is 24 times 24. Now I can do this by hand, or I can use a calculator. 4 times 4 is 16. 4 times 2 is 8 plus 1 is 9. 4 times 2 is 8. 2 times 2 is 4. So I think we're going to get 576. And we're going to go ahead and make that c squared. Now I can't do anything with this c because it is a variable. So what I'm going to do is solve the left side of the equation. We can go ahead and draw our mirror at this point. And I'm going to solve the left side of my equation so I can figure out what c squared equals. So if I add 49 and 576 together, I'm going to get 15, 8, 9, 10, 11, 12, 625. And that's going to be c squared. But I am not done because I want to know what c is, not what c squared is. So if you remember what we did in our warm-up, the opposite of a square is a square root. So what I want to do is find the square root of both sides of my equation because of my mirror, and that will tell me what c equals. Now I can go ahead and use my scientific calculator to help me if I do not know what 625 to the square root of 625 is. If I don't have that memorized, I'm just going to type, and bear with me, I think I have to go 625 square root. There we go. That's 25, and we can double check that. 25 times 25 is in fact 625. So the length of c is 25, and this is inches based upon the units in our triangle. So that is my answer. Okay. All right, now I'm going to go ahead and do that again, but this time I'm using this triangle, and you'll notice we have our hypotenuse. We know what C is. We're missing one of our legs. So I went ahead and labeled it A, and I rewrote my equation, my theorem here, just so that I know. And I'm going to say, okay, so A squared plus, we know that B is 12 squared equals 15 squared. And I'm just going to do the same thing that I did on this equation up here, except that I'm going to have to do some inverse operations to isolate my variable, just like we did in our last lesson. So you try it on your own. I'm going to go ahead and pause the video, do all of this, and then I'll join you again with an answer. All right, so you'll see here that I squared 12 to get 144, and I squared 15 to get 255, and I just did that on my calculator. And then to isolate A all by itself, I went ahead and subtracted 144 so that I could get rid of it and move it to the other side, leaving A squared by itself and 81 on the other side. So the last thing I have to do is just find the square root of both sides, and that's going to give me A equals, and we should have this one memorized, 9 times 9 is 81, so A is 9. So this leg of my triangle is 9 centimeters. And that's how we do it. Now, of course, we have to have our math with our word problems here. So we have a box, a shipping box. Oops, went away. That is used for shipping narrow copper tubes, and it measures 6 inches tall, or in height, by 20 inches long. It's 6 inches tall and wide and 20 inches long. What is the length of the longest tube that can fit in the box, given that the length of the tube must be a whole number of inches? So we're going to try to figure out the longest tube. Now, you could fit a tube this way and that would be 20 inches, but if you didn't know, the diagonal of the box is going to be longer. And if you go from top corner to bottom corner, that's also going to be a longer tube. So really R is going to be the longest tube that we could fit in this box. Now also, if you notice, we started to make some right triangles inside of this shape. So I'm just going to outline them a little bit. So you can see here we have this triangle on the bottom, and I know that it's a right triangle because all the corners of a box are right. And then we have our purple triangle here, which is kind of three-dimensional in a way. It's standing up in the middle of the box, okay? And again, I know that this is a right angle because to go from top to bottom, that's going to be 90 degrees. So I can use what I know about Pythagorean theorem to solve this problem. So what I'm first going to do is figure out what S is. Now, I know that 6 is the measurement of the side of the box, the width here. So this is 6 and this is 20. So I went ahead and did 6 squared plus 20 squared will equal our hypotenuse of x squared. So I'm going to go ahead and solve that. So I went ahead and squared the 6 and the 20 and added them together. And now I just have to use my calculator to do 436. Find the square root of that. Notice that we get a really long number here. So we want the length of the tube in whole inches. And because our tube can't be part of an inch, we're going to just round down to 20 for this one. So we're going to say that that is approximately 20 inches there. It would be a pipe that could fit diagonally and flat. Now, if I want to figure out the triangle on the purple area here, I'm going to go ahead and take the unit of S, which I'm saying is 20, and square that. And then the unit for the height, which is 6, and square that. And I'm going to make that equal R, my hypotenuse. But if you look, this equation right here is identical to this equation. So I know that R is also approximately 20. So 20 inches would be the maximum length of tube that would fit in our box. So go ahead and just practice these two on your own here and see what you got. Take a pause in the video. Solve the problems, and then I'm going to have them all solved out at the end here so you can check your work, and we'll see how you're doing. All right, so you can see that on the left here, we're trying to find the hypotenuse. So I did a squared plus b squared, 30 squared plus 40 squared equals c squared. We went ahead and used a calculator to help us calculate this. We found the square root on both sides, and we got 50 feet for our hypotenuse. And then on the right-hand side, we did the same thing, but we did a squared, which is our missing side, plus 40 squared equals 41 squared. Again, with the use of calculator and some basic math, we found that A is 9 inches. Now, if you're ever confused going, I don't know if what I did was right, you can always plug it back into your formula. 9 squared plus 40 squared, does that equal 41 squared? You can do the same over here and do 30 squared plus 40 squared and just double check your work. See if that's true and use your calculator to see. And if you do that, though, you'll find that we are right on both sides. All right, good luck working with Pythagorean theorem.